Today I would like to show you how quite easily you can build application which is receiving data from LoRa sensor. For example, sensor which is measuring humidity and temperature. And this data are sent to the Things network, and we will read the data from the Things network and store it in Influx database. And in the end, you will see beautiful charts in Grafana. And there we can see, how, for example, or what actually temperature or weather we can, for example, see in a room. We will use DHT sensor. I will also share all code, everything what we will do here on GitHub. So you can later on try do the same things by yourself. We will use in our examples DHT sensor, but in GitHub you will be able to find also for sensor source code for BME 280, which is measuring temperature, humidity, and also pressure. DHT sensor, it measure humidity and temperature, not pressure, but in our demo, we will work only with the temperature and humidity. The LoRa device we will connect to the Things network, which is a community-driven LoRa network. We will use a Docker. Docker we will use actually to build a local environment because it will allow us quite easily to have a local instance of Grafana, of the Influx database. And also we will create a simple Node.js application, which actually will be used as a bridge, which is reading data from TTN network and storing this data in Influx database. Here you can see of our actually IoT monitoring that we will do. We have a few LoRa devices which are represented here by end device 1, end device 2, and end device 3. The gateway here, it represents a gateway which is actually receiving data from a LoRa nodes. These data are transformed actually from radio signals to a JSON structure, and this JSON structure is sent to a TTN server. Communication between a LoRa node and gateway, it's over a radio network. And for communication between LoRa gateway and TTN server, there is a used MQTT protocol, which it's a simple protocol for publishing of messages and receiving of those messages. It's like publisher and a subscriber concept. The TTN provide various APIs which we can use to access data. Unfortunately, TTN normally doesn't store the data which you collect from LoRa nodes, but they provide various integrations, and also they have an API which allow you to access the data which are sent from LoRa nodes. You can use MQTT protocol from your application. In our case, the TTN Bridge, which is reading sensor data through MQTT. It's written in Node.js just to keep things simple. I will also show you actually how that API works. We will also look how, for example, or which SDKs we can use for TTN, because for TTN you can use various SDK like in Java in Node.js, in Ruby, and in other platforms. And if I look back at our TTN bridge, so it's a simple application which has just one simple task, and it's to listen on a topic, which actually topic, it's in a publisher and subscriber concept, something like a let's say folder to which the server will send some data on some condition, and we can get this data, which is actually a JSON that we get with data from a LoRa node, and TTN Bridge is reading data from this JSON structure and storing them in InfluxDB, and Grafana in the end is displaying some charts. On the following slide, you can see our LoRa node, which we are using in this demo. We are using a microcontroller from Adafruit. It's actually Adafruit M0 LoRa. You can see here that we have there connected a DHT sensor. In this case, it's a DHT11. This LoRa node is sending in a time interval of 15 seconds data from the sensor. We will also look how, for example, this code looks for the LoRa. I will also show you how, or actually what we need to do in on TTN side, how we can, for example, set up something like an application to which this device is sending data through gateway. Just one thing is here that the LoRa device is not sending directly data, measured data as a JSON structure. It is sending data as an array of bytes. And on TTN side, we can use something like a payload function, and that function can actually transform that array of bytes to a JSON structure, which we can receive in our MQTT bridge. I'm sorry, TTN bridge. It's actually this guy, TTN bridge, written in Node.js. And the reason why we are not sending the JSON structure directly from LoRa node, so it's because we are trying to because usually the LoRa devices are for example using the battery, and the battery it's something what can provide you power for a LoRa node for a time, and that time can be like, for example, in months, in years. It depends how often you are sending, how frequently you are sending data to a gateway, and also how many of data you are sending. So it's much more better for us to send an array of bytes instead of a JSON structure. For example, if you have a device which is measuring humidity and temperature in a location, and you have there a battery, and you want to, for example, have running this device for 3 years. So for you, it's mean like a developer and also creator of the device to be to think twice how, for example, frequently you will send data and how much of this data you will send. So later we will look more how actually that payload functions works and what we can do with them. About Influx database, so just a few words. It's a time series database which it's ideal for collecting data from IoT sensors. Actually, we are storing a value which is recorded for a particular timestamp. And it's not like, I mean, this InfluxDB, it's not directly similar to SQL databases, as we can know, but it's not difficult. It's quite easy to work with them. And later when we will go through code for TTN Bridge, that how it actually works, that in InfluxDB we have still something what we call as a database. The measurement, that's something what is similar to a table, for example, in the terminology of SQL databases, and so on. And the final result, which we should be able to see, it's a chart in Grafana. The Grafana, it's an open source tool which allow you to create various dashboards. On the dashboard, you can have a charts, you can have there, also you can have, for example, alerts. For example, if data like here would, for example, reach, I don't know, 28 Celsius degree, so it can trigger an alert and inform you that, for example, temperature reach that value. So that's basically what we will do. So we will do practical demonstration of sending data from LoRa node to TTN network. We will do practical thing like of integration with TTN, and also we will look how to work with Influx database and how to use Grafana. Question so far? So at first, what we need to do is to look at actually the code which we have on LoRa device. There exist multiple ways how we can actually create a LoRa application. You can, for example, you can use Arduino to create simple application. There also exist various libraries which you can have for which actually provide a stack for communication with the gateway, for connection there, and so on. We are using the library called LMIC, which is a simple LoRaWAN stack. And this stack provide functionality, I mean like functions that allow you to send data, to receive data from the server, and to do some other operations. I will not go much detail how the LoRa works, because for this we have or we had actually another workshop. We will in future return to a LoRa topic and learning how it works in detail. Again, here I just will say that if you want to connect to a LoRa infrastructure, so there exist two ways how you can connect, and maybe before we will look at this code, so I will actually show you what you need to do on TTN side. First, what you will need to do is to log into your account at the Things network. If you don't know the Things network, so they are running the website, the thingsnetwork.org, where you can find a lot of information about the Things Network project. On this map, you can see that there exist thousands and thousands of the gateways on multiple locations. Again, the gateway, it's an important device which allow you to connect your sensors to TTN infrastructure. TTN console, what you will need to do is to create application. Application, that's something what you need to do at first before you will be able to connect your LoRa device to the gateway, or in general to LoRa WAN infrastructure. Basically, the application can be dedicated to a sensor or to an application. In our case, for example, we have a couple of LoRa nodes with DHT sensor, and so we created here application called HDB, like a HackTheBase IoT monitoring DHT. And under this application, we can manage our sensors. Currently, you can see here that we have actually two devices. Two devices are sending data. If I click here on a tab called data, so you can see actually data which we are receiving right now from individual devices. You can see here a unique ID of a device, which has to be unique for an application. You can see the payload. The payload is actually a set of bytes that you are sending from the server. And here you can see actually human reading values from that payload. That's actually the JSON structure which we are creating by payload formats. But I will return to this part later on. So back to devices. If you want, if you want to connect a device to like a LoRa node to TTN server, so what you need to do is to create here, or actually to register a device. That registration of the device, it's something like to create a profile. If we will take a look for device 1, so we can see that this device has here, for example, is providing the status. It's a, it was contacted for last, and because this device is sending in interval of few seconds, so you can see that after 15 seconds it again resetted the counter to 1 second, and we can see that the device is sending here data and we are receiving the payload. Activation method, it's basically the way how you can connect LoRa node to TTN server. There are two ways. There exists actually ABP, which is like for it's a good for testing, for development, but it's not good for production for one reason. If you want to connect, for example, this device 1 to a TTN infrastructure, so you need to provide actually in your Arduino code a device address, network session key, and application session key. Three values are unique for your device, actually device 1, and you shouldn't use it for another one. So if I now switch back to Arduino, so here we can see the part called device address, and we can see here this number ending with E8. And if I switch back to TTN console, so you can see basically that this number is that device address, which we need to provide in Arduino code. The next thing which we need to do is that we need to copy the network session key here and add it here in Arduino code, this part. And the last part, what you need to do, it's to provide application session key that you also need to copy here and put here. And now, because we have this free information like a network session key, application session key, and a device address, we are able to connect the device to TTN infrastructure. For example, check now device 2. So you will see that device 2 has a different number. For device 1 we had E8, and for device 2 we have EB in the end here, so it's a different. Method can be changed in the part in the tab settings. So if you go there, so actually you can choose which activation method you want to use. OTAA, it's an activation actually over air, and this method allow you to register device to TTN network. So it's mean that you don't have to provide a dedicated device ID as we have it here. And that's something what we should use for production implementation. Okay, so that was the part how to create an application in TTN, because that's the first step which we should do before we can connect our LoRa nodes. The second step, it was to register a device, which is actually something like a profile. The next step, when we have an application and we have a registered device, so we can actually create a code and upload it to our Arduino device. Sensor, we are using the library from Adafruit. Adafruit in general, they have very nice tutorials for various sensors, and they provide also the libraries. And in this demo, we are using the Adafruit DHT library. Next thing which you need to set up for your LoRa node sensor is on which pin is available a data wire from a DHT sensor, and which type of DHT sensor you are using. There are actually two types, like a DHT11 and a DHT22. If we look back at actually the picture of our LoRa node, so you can see that second please, that this is a data cable which is connected to a DHT11 sensor. Here we have pin number 9. This microcontroller, it's powered up by USB cable. Here we can connect a battery. It's a 3.7 voltage battery. Here we have a connected 3 volts. This is a GND. And we have here also a resistor. And this is an antenna which allow us connect this LoRa node to a gateway. Even this small antenna, which has I think 8 centimeters, so it if there are good conditions like good visibility to gateway and so on, so can reach the gateway in distance of almost 2 miles, which is a quite good result. Okay, so that's how actually we connected the HT sensor to microcontroller. It's a true pin number 9. You can see actually the frequency, how often we are sending data to TTN. This is just only a mapping which say on which port numbers we have connected the LoRa module. If we look back at the picture with our LoRa sensor, so this is the LoRa module, and here you can see some wirings that we did, and that's actually like a pin numbers that say how that LoRa module is connected. The next thing what you can find in this Arduino code, it's a method called event. And this on event actually help you, for example, to manage various events that can, for example, can happen. For example, when you have successfully sent data to LoRa gateway, so you will receive this event, and you can schedule sending of another event. I will show you the console. You can see what data we are right now sending from LoRa node to gateway. So as you can see here, we have the readings from the HT sensor. Here we have scheduled a packet, and here we have like that sending of data was successful. How actually communication between a LoRa node and the gateway works. So we have actually two type of events, like a uplink, which is actually the event when you send data from your LoRa node to the gateway. And downlink, it's something what can be used, for example, to send a command to a LoRa node. That command can be, for example, that you can change some configuration, like frequency, how, for example, how frequently send data. So if I have now a time interval 16 seconds, so I can, for example, have an implementation that will receive a downlink message, and that downlink message will, for example, tell me that I want to change that frequency from 16 seconds to 5 minutes and so on. Or that a downlink message can have a command that can, for example, can start engine or stop engine and a lot of other things. There is one important thing about downlink messages, that downlink message you can get only when you send an upload message, basically when you send some sensor data to a gateway. So as a part of response from the gateway, you can receive that downlink message, and it can be a command that can take action. So if you see here, so basically in this part we have something like checking if we have received data, and if yes, so it means that here we have a downlink message. I think I can show you how that downlink message work. Let me show it, just like a demo. And I will need also run real console here. let's try to send downlink. So again, when we are in our application, see here a list of devices. So you go there. Let's say that we want to send a command to device number 1. So you go there and you can actually simulate a downlink. So let's say I want to send there, for example, this payload like 1, 2, 3. I can send it. Shortly, I should see here in console that I have received the payload. Yes, as you can see, we have received a command from a gateway. And basically, that's what you can do in your application, because you can do a downlink operation through MQTT, for example. And that's, for example, how your application in Node.js, in Java, and so on, can control remotely the LoRa nodes or a LoRa device. And you can actually control a set of devices. In this case, I just demonstrate this thing for this one device 01. But if you will, if you will use the API, so basically you can remotely control, configure a bunch of devices. Yeah. Yeah. Um, um, yes, that's also an important thing that I didn't mention, that the LoRa operate in various frequencies. The LoRa node which we have here, it uses frequency 915 megahertz, which is for North America. For Europe, you have 868. It uses free frequency. I mean that you don't need any licensing for that. And the LoRa node, which we have here from Adafruit Feather M0, so this device from Adafruit, it works in both regions. So you can use it for frequency 915 megahertz, and you can use it also for 868, which works in Europe. So basically, you can create you can create a sensor node which can work in Europe and in North America. But you need to configure your firmware for this. So you want to, if you want to, for example, run this code on LoRa node and operate it in with frequency 915. So you need to set up configuration for LMIC. There is a configuration file called config.h. I will show you how to change it. So when you have installed on your machine LIC library, so you can find there config.h file where you can change the settings. So for example, if you want to use your code for 868 frequency, so you need to make sure that you uncommented this one. If you want to use device for North America region, so you need to uncomment this 915 frequency and comment 868. Okay, so that was the way how actually we are sending data from a LoRa node to gateway, how we can, for example, receive a command action. I just put or edit a method doSleep, which does one thing that it sleep for that 16 seconds. That time interval you can change in if you change the property tx interval variable, I mean, and sleep method, or let me show you a method doSleep, how it looks. At this moment, I'm using delay here because just only for this demonstration. But if you have a real project where you need to put your device to sleep mode to save the battery, so you cannot use a delay because it just only wait for a time, and after that it continue and it doesn't save battery. But there exist various libraries, for example, library called SleepyDog, which is from Adafruit, and that help you to sleep, to put a device to a sleep mode. There exist also some others that you can use, but for to keep this demo simple, I just use delay here. But this doSleep method can be updated, changed, and you can implement there doSleep for putting a device to sleeping mode to save battery. You can use some other libraries which works here as well. Method doSend, that's actually the method which read data from a sensor and send this data to server side. I just create here a buffer for data. That buffer has length of 6 bytes. And in method read DHT, I'm just adding data from a DHT sensor. So have a look at read DHT. So from DHT sensor, as I mentioned earlier, you can read humidity, you can read the temperature, and you can read also temperature in Fahrenheit. And this all free data we are sending in our data buffer. It has a size of 6 bytes, and actually here we are using like a high byte, low byte, just to store the, because 1 byte can have like a 255, like a maximum number. If you want to use, decimal numbers and so on, so we need to use a 16-bit number. Because the data which I'm getting from DHT library, which is responsible for reading humidity temperature, it's a float which has a decimal number. And, as you can see, decimal number, that's something what I need to send, to server, because it wouldn't be probably good to do monitoring and see only like numbers like 26 for temperature, 27, and so on. So I have here a small trick that I just do, let's call it something like a conversion from float to integer by this operation. And on TTN server, I have a function which is actually transforming it back to float number, and it also transforms these bytes to JSON structure. So let's have a look how actually I am working with these bytes on TTN side. If you go to back to your application, so you have here a tab called payload formats. In payload formats, you can create a function that can help you actually to do decoding of a payload, which should be an array of bytes. you can see that I am actually decoding from the bytes the temperature in Celsius, F it's a temperature in Fahrenheit, H like humidity, and this it's creating a JSON structure. And this JSON structure later on we will use for integration with InfluxDB, because our TTN bridge will actually read this JSON structure and will actually read data from this JSON and store it in Influx database. If we want to see, how it looks, so we can go to tab called Data. And here you can see the payload. You can see that we have there 6 bytes, like first 2 bytes are temperature in Celsius, another 2 bytes are temperature in Fahrenheit, and the last bytes are humidity. And below you can, not below, sorry, here you can see humidity, temperature, temperature in Fahrenheit as a JSON structure. So far, yeah, so this part, like a DHT, humidity, temperature, temperature F, that's very important because that's what we need to read in our TTN bridge. We can store it in Influx database. And so I return back to TX complete event. So we look how actually we can do a sleep. In this example, we are not using real sleep. We just emulate it by a delay method. But in real project, or maybe not, I should call real, but for production, it should be a real sleeping mode. Like, for example, you can use the library sleepydog from Adafruit. In method doSend, we are actually reading data from DHT sensor and sending this data to gateway. If I go back to doSend method, so the method which allow us to send that buffer to gateway is actually this one. It's set tx data. And you just say here the data buffer and the size of the data buffer, and that's it. Setup method, Arduino code has 2 main methods, like setup, which is run only once, and it's used to configure your application. For example, you can set up the serial ports. You can, for example, configure a DHT sensor, and you can also configure a LMIC library to be able to connect to TTN. And the last method, which is important, it's a loop. It's actually which is running in infinite loop, and it's doing something what you have there. In this case, it's running that code for LMIC library, and it's checking if there is something to send to gateway, or if there is a, for example, downlink message, and so on. And that's basically all about the firmware part. So as you can see, it's not too complex code, which read data from sensor and send it to TTN. So the next step, what we will do is we will look at TTN Bridge, which is Node.js application. The old code that you can see here, and you will see that's something what we will have later available on GitHub. So and also we have a Slack. So if you will, for example, try it in a couple of days and you will have still questions, so you can use our Slack channel, and we can help you with any other questions that you might have later. So here we have an application called TTN Bridge, and as I mentioned, it's an application that we use for reading data from TTN through MQTT protocol and sending this data to Influx database. So let's take a look at that TTN Bridge application. The Node.js, it's a quite simple way how you can create application. For example, like in this case, we have application which is reading data. It's still a JavaScript, so nothing difficult, I think. And at first, we will look at the way how we can connect actually to TTN. So as I said earlier, we will look at the API possibilities at TTN. Okay. So this page, it's the best way where you can learn about integrations with TTN. As you can see, they have various languages supported, and maybe before we will look more closely at Node.js, I just want to show you actually how that MQTT protocol is used for communication between your application and a TTN server. As I mentioned, MQTT it's based on the concept of publisher and subscriber. It uses a topic. Topic, as I mentioned, we can imagine that like a folder where we can store some data. And this data are available only temporarily for subscribers. And when all subscribers get it, so it's not longer available there. And we can subscribe to various topics. One of these topics can be, for example, topic which allow us to receive messages, uplink messages from devices. What you need to do is that your topic or topic to which you need to subscribe, it's like your application ID, which is in our case application ID you can find here. It's in our case HTTP IoT-monitoring-DHT. Devices. You can receive, for example, data from all devices. Just, register to particular device. And device ID, if we go back to devices, you say I want to get the uplink. You can see a JSON structure that you will receive. You can, yeah, we can, for example, try this one. You can use the Mosquito. Mosquito, it's a open source client and also server or broker, I maybe should say, that help you run your own MQTT server, but you can use it also as a client because this Mosquito sub, it's like a subscriber and it's a client. So let's try connect in console. First, if you want to connect to MQTT server, you need to provide a server address. In a TTN, we need to choose actually to which region we are connecting. It's like an address of MQTT broker because you know the TTN has multiple locations, multiple continents. To get the better performance, to get the data faster and so on. So they have multiple MQTT brokers, and we just need to choose from which to which region we want to connect. So let's take a look to which region is connected this application. It's TTN-handler-EU. And in console, I will actually add this handler. So now I have the server address. The next part, what I will need to provide, it's actually topic. Topic is, for topic, I need to copy actually here the application ID. Is ID, which is device 01 in this case. Okay. Okay. For example, on Mac, you can install the Mosquito line. On other platforms, you can use, pages for installation. There is also one thing, if you are connecting to MQTT as server, so you need to specify not only host and topic to which you want to connect, specify username and password. And now I will show you actually where you can find user name and password to MQTT. So if you go to your application and you scroll on the screen down, so you can actually see the access key here. It's the password to MQTT, and the user ID, it's actually the application ID. Each access key can have various permissions. Let's say I want to create new one, like a test. And now specify what you can do with that access key. For example, I want to just view or send messages. So that's default. Or if I would like, for example, to view or to update devices, so I need this permission and so on. For integration with, for example, that TTN bridge, we will use only role messages. It's still pink mosquito. Any questions so far? Is here anything, what I, for example, didn't explain enough, or something what you would like to ask? Hopefully, mosquito.
Tomas, if you just refer to the chat, I think Andreas had some questions, and so did Gustavo.
Yeah, in case of our demo, we are using here two gateways, like a gateway for North America and also gateway for Europe. So we have the gateway which can operate for frequency 915 and 868. Regarding the question, like for frequency for 3.3, which is also a free frequency. This is not so common. For example, or actually it's not available in America. It's something what you can use in Europe. You can use it also in some Asia regions. Regarding to update, a remote update of the firmware. So basically, it's not so easy for one reason. As I mentioned, the way how to send data to a device, that's what you can do only through a download message. And the downlink message you will get only in the case that you send, for example, collected data from sensor. You cannot use, all available amount of data in the air, because if you will try to send, for example, firmware which can have, let's say, 32 kilobytes or more to a LoRa node, so you basically cannot do that through a downlink message. Theoretically, it would be possible, but it's not practical. It's in LoRa, you need also follow something what we call fair user policy, which means that you send data quickly and disconnect, and you don't block the frequency for other devices, because you can have, for example, multiple gateways in one region. You can have a large amount of devices there, and it can be difficult. There exist some other ways, and basically the LoRa one itself, as we are using it, doesn't have the feature which simply allow you to update the firmware, as we can, for example, we can see for other microcontrollers like from Particle, where you can do a firmware update over air. But here it's not easy. There can be the way like that device can have, for example, Bluetooth mesh support. So basically, you will create your LoRa node. You will have their LoRa module, their Bluetooth mesh, which will not be active. You can, for example, use a downlink message to activate this feature, like, for example, to notify device that you want to update it, and you can use Bluetooth mesh network for updating. It's not easy, it's a quite very complex thing, but there exists a way, and especially when you are using the battery, so frequent updates can have an impact. So yeah, with LoRa, it's not easy to update, still challenging thing. Um, is this, Andre, is it by this way okay answered, or yeah, okay, you're welcome. Okay, so that's yeah, we have now a Mosquito installed. So the next step, what we will do is that we will try connect through to TTN server through via Mosquito client. We need to provide a user. Just now sure by one parameter. Okay, so the -u, it's for a username. So in our case, it's ID here. Password is here. Okay, yeah, and now we can see actually the payload, or actually we can see the message which is sending one of our LoRa node, and you can see here, application ID, hardware serial number. You can find there a lot of other things, but for us the most important it's payload fields. Because the payload fields, it actually has that JSON structure, which you can see here. And that JSON structure is what we created by a payload function. Again, the payload function, that's what you can find in application. And it helps you to decode the array of bytes, and you can use, for example, a JSON structure like this. In MQTT, when you are receiving data from MQTT in your application, so this is actually that payload that you need, and we will use also in our code. As you can see, it's quite simple. You just connect to a TTN MQTT broker. By reference, you can find that the address is the Things network. You need to provide a region. The region you can find when you go to application overview, and this handler has the region like this last part of the handler name. It's that region. And you can see that port 1883 is unsecured. The secure port it's a 8883. And the username, it's actually our application ID, and the password, application access key, which we can get again in application overview here. Nothing difficult. And yes, and you also need for MQTT here, I mean, that client specify which topic to which topic you want to subscribe and which data you want to see. So we want to see from our application, from our device, and we are interested in uplink message. So that's the most easier way how you can get data for your application. See also that there is another topic which allow you to get a particular topic. Sorry, a particular value from your payload. Let's say that I want to just get HD. So I can just say that I want to. This is the field name. It's a DHT. And documentation, you can see that if you don't want to receive, this large payload with a lot of data, you want to just get your fields. I mean, like that data that you will get through payload function. For example, here I can get a devoter, as you can see in this example, and it returns you a true, or I can use the text, and for the text it returns me this message. And in our case, for example, as you can see, so our payload has inside a field called DHT, because let's say that we can have a complex LoRa node that can have various sensors, and we are working on some project related to smart farming, and one of our sensor nodes it's using multiple sensors. In this payload, payload fields, we can have multiple, from DHT, from BME, and multiple others. And if I want to just, get JSON data for DHT sensor, so I can just say I want to data from a DHT field, which it's this topic. And below you can see that I'm getting only that payload, which is quite nice, and it's a quite easy for processing. Even you can use this Mosquito subscriber in some bash scripts, and you can parse those data and do some powerful things. Maybe in one of future IoT Garage, I will show you what the magic you can do with bash scripts and MQTT, and how easily you can build quite powerful applications with MQTT and just simple bash script. But that's another thing. Okay, so that's how we can get messages from TTN. If we go down or below in documentation, so you can see that there is another topic which can be used for downlink, and the downlink can be like a way how you can, for example, send a command to device, and it's very similar to upload messages. You can also get even, for example, when device was activated, in the case that you are using that OTAA activation method. If you remember, we have two activation methods, ABP, which is more for testing, and it will require to have a unique device ID directly in the firmware. OTAA, it's like an activation over air, which doesn't require to have hard-coded device ID in your firmware. And for any activation, you can actually have a topic, you can receive this message, and you can, for example, take an action in your application. And that's it. There is more thing about MQTT, but for our example with monitoring of environment through the HD sensor, it's okay. So now let's take a look at SDKs, because in TTN Bridge that we have here, we are using a TTN SDK library. So before I will go through code which I have here, so let's have a look at actually Node.js, how it works for TTN. So for each SDK, you can find a quick start, which provides you step by step how you can quickly create application. You just need to install a Node.js. If you click on this download link, so you can get to a website where you can find instruction how to install Node.js on various platforms. Then you have installed a Node.js on your machine. So what you can do is, you will create a folder, you will initialize Node.js for your application. What you will need to do is to install TTN library. That's what you can do by this command. After that, you can create a new file, open that, and at first you need to create a reference to TTN library. Second step, you need to provide actually the user ID and the password, which is in this case access key to TTN. Here we have a simple code, which is just for incoming uplink messages from TTN, and here we can process actually that messages. In this code, it will just only show you in a console that payload. The payload will be actually the same which we are getting here. That payload you will have there. And in the end, you just run this command and that's it. And you can see actually in console incoming messages from TTN. Quite simple. And now take a look, have a look at TTN Bridge. So in TTN Bridge, we need to use two libraries. At first, as I mentioned, we need to have a TTN library, which is allowing us to access data from TTN. And the other library, it's actually a client for Influx database. Here we provide actually the user ID and password for TTN to be able to get data. This part is actually for receiving uplink messages, and return a little bit later to this part and explain it. Below you can see initialization of Influx database client. And what we need to do, actually, we need to specify on which host the Influx database is running, which port it uses, to which database we want to use, and here, user name and password. Other thing what we need to do in our application is, before we will connect to a particular database, so we need to check, if the database if it exists. If the database doesn't exist, so we can create that one, and that's what we can actually do by this part of the code. Below, we have a function which is writing data to Influx database. Influx client has a method called write points, where you can have a set of data points that you want to store in database. Measurement, it's an equivalent to a table in SQL databases. The tags, it's would say that it's something like a key for indexing. We are using here a device ID. In our case, it can be like a device 01, device 02. And here we are storing actually the value for the temperature. That's one data point. So we have a dedicated table for temperature, and for each point we store information like from device, which device it is, and what value it is. The other thing is that we have here the second data point, and it's for humidity, and it's very similar to previous one, but instead of temperature we are storing the humidity. And this function called write data to Influx, it has one argument, it's a data, and that data, it's a structure which has inside a device ID, and it has that payload that we received from TTN. So now I will go back to part where we are receiving the payload from uplink message. Here you can see that I create a data structure that has a device, the payload, it's that JSON structure, I mean this one, from MQTT. And from that structure I get the device ID and the payload fields, because that payload fields that's the most important, because it contains the data from the sensor. And see if we will look at last message from MQTT, which I have here. So the payload we have here. Also see that we have the row payload here. So if you don't have, that payload function, so you can still get the payload row, and you can do processing of that payload in your application. This is actually what we get in DHT field, like humidity, temperature, and temperature in Fahrenheit. I just look that data structure just to see in console, what I have there. And here I write data to Influx database. To this part. Okay. So the next step is actually how we can run Influx database and Grafana on our machines. We will use Docker. Docker, it's a way how you can run your application as isolated container. Years ago, there was a very popular way with virtualization. That you can have a physical device, And that physical device, like a server, you can split to multiple boxes, which are actually the virtual machines. Virtual machine, you could have a different operation system, and that different operation system, for example, it could be like a Ubuntu, Red Hat, it could be CentOS, or it could be even a Windows platform or Mac, and run there your applications, and you could actually save the money for your hardware resources, because many years ago, if for example you needed to run two applications, like for example database and web application, so you would need to create for example a physical server. When you have a virtualization, you can do it on one box, on one physical machine. The container, it's something what is inside of virtualization. I know that it's not probably the best explanation what the container is, but the container is something what can run isolated environment, where you can, for example, run something like a Ubuntu, and you can run your application for Node.js, have a container where you are running Red Hat, and you are running there, for example, JBoss for your Java enterprise application, and so on. And also, containers allow you to set up, for example, or run multiple applications on your machine. And that's basically what we will do right now. We will run on our machine three Docker containers. Container will run Influx database. The other one will run the Grafana, and the last one will be our TTN Bridge, our Node.js application. Docker itself, it's a tool engine which is running the containers. You can create a container, you can stop the container, and you can do other operations. And there exists also a tool called a Docker Compose, which is a tool which can do some kind of orchestration. Orchestration, it's mean that you can create a template, and in that template you can create a list of containers that you want to run, and you can also provide some configuration data for that containers. And yeah, that's the next step. I will actually show you how we can create a template in Docker Compose. For this, we have the file called docker-compose.yaml. And here we can actually specify services like our containers, and we can specify here like a database, Grafana, and our TTN Bridge. Each container or each service exactly here, it needs to have following like an image. The image, it's actually the let's call it a package that contain that application that you run as a there. So this is the InfluxDB here is the name of image, and each image can have a various versions, and that version here we called a tag. For example, 1.7.8, it's a version, but in Docker terminology we use it as a tag. There exists a place where you can have a lot of, where you can find all those Docker images. It's called a Docker Hub. Here you can search for various images. Let's try that Influx to find. So this is the page where we have Influx database, and we can see here, terminology tags, which is actually something like a version. And you can see a bunch of versions that you can use. And in our demo, we are using version 1.7.8. Also specify a name of the container. Basically, this name, it's also the host name of that container. Because when you run, for example, these all three containers together, so you can actually communicate, these all containers can communicate each other. And instead of using port numbers, you can use, for example, the name of containers. So expose the ports. It means that, for example, you can forward the port from the container to your machine. The volume, it's actually the folder that you connect to virtual to container, and in that volume you will store, for example, data. In this case, we will store on the volume data from from database. Restart always. It just say if the container crash, so it will restart it automatically. The Grafana. So again, we need to specify the image, which is this one, the version, the container name. It's Grafana. Here we say that Grafana has a dependency on InfluxDB. So if InfluxDB will not be running, so Grafana will not run as well. Grafana, it uses the port number 3000, and we are exposing. Exposing, what does it mean? For example, if I now expose the port number 3000 from that container to my machine, so I can access the Grafana just by this way. You will type localhost, you will use port number 3000. You can now access your Grafana. We need to store some data, like a configuration from the Grafana. So we need also the volume for Grafana container. And the last, it's our bridge. And because we don't have our TTN bridge container, or actually in this case, it's an image on, the container, it's an instance of an image. Image, it's like a package storage where we have our application, we have there all settings and so on. And by build, I actually will build that Node.js application as a Docker image. In a few minutes, I will show you how we are doing that actually, because it requires to have file called a Docker file, and in that Docker file you actually specify what in that Docker image will be. This is the name of our Docker image. If you don't use a tag, it means that you don't use here double dot and a number. So it's using a tag called latest. So it will use the name latest. So it's something like this. And we have here a name of the container, which we can use also as a host name inside of the Docker networks. We say that also this container will not start if InfluxDB is not up and running, because for now, so also in TTN Bridge, we are using InfluxDB. So these two services shouldn't start if InfluxDB is not running. If the service TTN Bridge fail, so we will, so it will be automatically restarted. And now how we can run it. So created a bash script for this. It's called a run.sh. So let's have a look how that run.sh script looks. We have here two the first line in Bash in script in general, it say which shell you are using. I'm using here a Bash. In these two variables, we have actually like the name of Docker Compose command, and here we have actually the folder. I will share. I will share everything what we are doing on GitHub. Yes, include the presentation. Everything will be there. And also, I'm doing recording of this event. So when event is finished, so I will share it so you can have a look. And variable data there, it actually say where we want to store data for InfluxDB and for Grafana. So it will be in the directory when you will run that script. This just create directories for data of InfluxDB and Grafana. We need to set some permissions, and for this demo we can use this 777, which we shouldn't use on production, but for this demo should be fine. And this is actually the command that we will use to run Docker Compose. Docker Compose itself, it has actually two parameters. It's like a Docker Compose space up, which say run that compose file, and -d, it say run it in background. So you actually will have it running in background, and you don't need to start it, for example, after reboot of the machine. Probably you noticed that in that Docker Compose file, I'm using a variable. And now that's a question how we actually get this variable in the Docker Compose. This environmental variable, if you want to use, so you need to do one important thing. You need to export that variable, or you need to use this magic keyword env, like an environment, and here you need to set data dir variable, and that it's equal to data dir variable, which is here. That's it. That's actually how our run script looks. So let's try to run it. Yeah, and for first time, what you will need to do is that you to assign permission to executable permission for the script, and that's what you can do by a command chmod, like a change mode, +x, like add executable, and the name of script. So when you will check that file, so you can see that we can run it. So let's try to run that script. See that InfluxDB is running because I ran it a while ago. Waiting TTN Bridge, that's what you can see there because I modified that Node.js script. If you now type command docker ps so it will show you the containers, and you can see the name of image, include the version. Again, the container, it's an instance of an image, so basically you can have multiple containers running, for example, TTN Bridge. You just need to have a unique name here. See how long that script it's running. In my case, Grafana and InfluxDB, it's running for a while, but because I changed code in the Node.js script, you can see that it was started. And here we can see the name of our containers. So the next step, what we can do is that we can, check the console, like output from TTN Bridge, and you can see that we are receiving here actually a payload from TTN. Again, if I will return back to Node.js script, so in this part code, which is responsible for receiving uplink messages, I am using the console.log, which actually that data structure on standard output. So that's what you can see. Next step is that we can have a look at maybe I will do one thing because just would like to start data for Grafana and InfluxDB. So I will do one thing. I'll stop all my containers. For this you can use docker stop and the name of container. And I will just, delete existing data for Grafana and InfluxDB, and we will start with the fresh you can see folder storage. If we will check what we have in storage, so you can see that we have there folders Grafana and InfluxDB, and each of these folders is actually keeping configuration data. And because we want to start from the scratch for Grafana and InfluxDB, so I will now remove Grafana and InfluxDB folder. Storage folder is has been removed. If you will check the run.sh script, which is actually for starting our Docker containers, so you can see that this storage folder in your current folder is created here. So if you delete it, no worries. Yes, you lost your settings there, but application will work, for this demo, so no problem. It's not production or something critical here in this demo, so I will run it again. So now we have a fresh installation of the Grafana. Let's see if we are getting data from TTN to Influx. Start look. Okay. I just need to restart Influx here. the reason why here we have an error which say that we cannot connect to InfluxDB, and it's because I deleted a folder with data and I didn't restart the container. So that's the reason why I did it right now. I should do it also for TTN Bridge. Okay, so now it works. This error message that you see, it's from previous running, because the Docker is storing and keeping history of console output for a while. So when you start or when you show log of the container, so you can see also some older messages. But now we can see here that we are receiving data from TTN. We are storing this data in TTN. That's fine. So we can go to Grafana. By default, the Grafana has account like a user account with name admin and password with admin. See, we are using the local host here, port number 3000. Again, number we can find here. You can see the container Grafana. Grafana, it's exposing the port number 3000 to your host. So basically, you can access the Grafana from that container by this way. Okay, so the user ID, it's admin, password, it's admin. So now we can log in. For the first time, you just want to change the password. So you can change or you can skip it for now. And yeah, this is the Grafana. Before, we can create a dashboard and to see, any charts and so on, we need to configure a data source. Source, it's actually something like a stream, or not directly the stream. Actually, the way or source how to get some data to Grafana and to do a data visualization of this. Grafana supports various data source types. You can use, for example, Postgres. You can, for example, read data from Prometheus, Elasticsearch, and so on. But in our case, we will focus on InfluxDB, where we have a data from a TTN. So on this screen, we need to configure InfluxDB. So the first step is that we need to actually say on which address the Influx database is available. And we will use the container name, because the container name can be used as a host name inside of the Docker network. Again, if I switch back to console and we check this Docker ps-a switcher, so in the column names you can find actually the name of the container, and this we can use as a host name. Name which we are using, it's IoT monitoring. That's what you can find in the script. IoT monitoring. Just a note regarding username and password. default Influx database Docker image. It uses username root and password root. So if you are, for example, trying or going to create something for like a product or something what can access the people outside, so you should change that default password. Okay, so we have database IoT monitoring. That's where we need to connect our Grafana. We need to provide credentials like a user ID and password to Influx database. So it's that root as a user and password root. Below you can just find some, let's call it good practices, how you should configure your account for Influx database, but you know, it's okay. So now we have configured data source, but before we can use it, we need to save it and test it. So just click, if we click on save and test, so we can see that Grafana successfully connected to Influx database, and also it saved the settings. If you click on back, so we return back to configuration of our data sources, and we can see that we have there our Influx database. So that's the first part for for Grafana configuration, and the next it's actually to configure a dashboard. You have a panel where you can go to home, and here we can create a new dashboard. On the dashboard you can add various gadgets, and let's try to add there gadget for like a graph or temperature. Before we will configure this panel or gadget, we will need also we can maybe change just a name of the dashboard. Let's call it IoT monitoring. Step it's to configure this graph. Here in this part we need to choose from which data source we want to actually display data here. So it's that data source called Influx database. The next step is to choose, if we want to have here a temperature, humidity, like from which table or from which measurement we want to see data. So let's try temperature. And now you can see some data here. So let's go back. And yes, we can see now that we have here some data. We can also change the name. It don't have to be panel title. We can have there something would make a sense for us, and we can do that in general tab, and it's a temperature. Dashboard IoT monitoring, graph temperature. Now it would be good if we would, store, save configuration of this dashboard. Otherwise, you can lose it. So don't forget to click on Save Your Dashboard Settings, confirm, and that's it. Your dashboard and its settings, it's saved. The next, what we can do here is that we can add the other, the other chart, graph, which will show you a temperature. Let's have it here. We have to select a data source. For us, it's an Influx database. We need to choose also from which measurement we want to have a data. It's humidity. You can see we have here something. We will change also the name of this graph to humidity. On left side, we have data from temperature. On right side for humidity. Again, it's good to save our settings. Here you can actually, for example, choose how, for example, often you want to refresh the data on dashboard. So let's say I want to have new data each 10 seconds. You can also, for example, choose how old data you want to have. For example, I want to have it, I don't know, like last 15 minutes. This, or last 1 hour, last 12 hours, and so on. So basically, you can have here various range for data. And that's it. So as you can see, it wasn't probably so difficult to create a LoRa sensor node that it's reading data from a DHT sensor. This data we are sending to a TTN infrastructure using a Node.js to read this data through a MQTT. That application in Node.js called TTN Bridge is basically storing that data from TTN in Influx database, and the Grafana we are using for data visualization and for displaying data from Influx database. Okay, so that's the part about how we can monitor environmental conditions like humidity and temperature, how we can do it step by step. And now we have here a question and answer section. So questions, anything you would like to ask? Next week we will have, the other IoT Garage, and we will have there another webinar. In IoT Garage, we will focus on other topic, and we will work with Wi-Fi devices. We will learn how to install the MQTT server, or MQTT broker. We'll do something similar with Grafana, but we will try to look more in detail on Grafana. Just not to display here temperature, humidity. We will have here some, charts, for example, about consumption of battery. For example, what is voltage on battery connected to your sensor node. We will also look, for example, what percentage of the battery left. We'll try other interesting things, because here we use, for example, directly a library from TTN to get the data from their MQTT servers. But next week we will look more in detail how you can actually create an application, connect to MQTT, read data, and we will also do one thing, that we will have an application that will send command to device back, and that device will do something. For example, it will flash diode, LED diode, and so on. Okay, so that's all for me today, and maybe in 2 days I will share more details about another IoT Garage, which we will have next weekend. Again, you can come, if you are in Vancouver, to our office. You can try to build a device. actually try to play with some microcontrollers and so on. And in afternoon session, we will try to build an application that is actually, for example, reading data from that sensor that you built in our office. And you can try some advanced things. Okay, that's it. Thank you, and see you at another of our IoT Garage. Thank you. Bye bye.